Hello everyone, welcome to Hacker Heap. In this video, we will look into solving the problem largest divisible subset. Let's go through the problem. Given a set of distinct positive integers, find the largest subset such that every pair S of I, S of j of elements in this subset satisfies either Si mod Sj is equal to 0 or Sj modulus Si is equal to 0. So let's look into this example. So if the given input is 1, 2 and 3, the output should be either 1, 2 or 1, 3. The reason is 1, 2. 2 modulus 1 is equal to 0 and 3 modulus 1 is equal to 0. So you can return either one of it. And remember 3 modulus 2 or 2 modulus 3 are not equal to 0. So that doesn't come under a set. So the second example is 1, 2, 4, 8. So we need to check the output should be 1, 2, 4, 8. The reason is if we are traversing through this, 2 modulus 1 is equal to 0. So these both of them will be in a set 1 and 2. And 4 modulus 2 is also equal to 0. So this will include to this. And 8 modulus 4 is also equals to 0. So we will include this. We need to check if 4 modulus 1 is also equal to 0. Since it's already there in the list, we won't be adding it. And similar to this, 8 modulus 2 is equal to 0. Since it's already there in the list, we won't be adding it. And similar to 8 modulus 1 is equal to 0, it's already there. So the return should be this. Let's take a different example and see how the output should be. Let's take this example of 1, 2, 3, 8. So the output should be the maximum subset which are divisible modulus is equal to 0. So take a moment and think of the output. So the output should be 1, 2, 8. There are two subsets where the modulus are equal to 0, 1, 2, 8 and 1, 3. But we should be returning 1, 2, 8 since it's the largest subset. So how do we do it? In the question, it never said the array will be in sorted order, but it will make us life easier if we sort the array. The first step is to sort the given array, sort of nums. Now we got it. So what we need to do? We need to maintain the index of the largest maximum set. So now when we are traversing through the array, we come through 1. If the list has only one element, we will be returning that as the subset because it is divisible by itself. So 1, here the max is 1, the length of the list, and the max index is equal to 0, the index 0. Now we go to 2. We know 2 is divisible by 1. 2 modulus 1 is equal to 0. Now the maximum number of elements is 2 and the max index changes to 1. Now coming to 3, we will loop back. We will have 2 for loops where we will loop back. So 3 modulus 2 is not equal to 0. So that doesn't include in this subset. And 3 modulus 1 is equal to 0. So these two become a subset. Now we got like two subsets, 1, 2 and 1, 3. Now still the max is 2 because the length of the second subset is equal to 2. And the max index, you don't have to change the max index because you can return either one of it. Now coming to the last element, so we check if this is divisible by 3, which is not, and it is divisible by 2. What we do is we will change the max index to 4 and the max would be 3. We start from, so how do we know? Like we need to keep track of the indices of that subset. So now we are here, 8 mod 2 is divisible by 2. And we don't have to do again like if 2 is divisible by something else because we will store the index. So we will take an index array where we will be storing where it is divisible by. So this will be basically -1. 2 is divisible by 1. So we will add 0. And 3 is divisible by 1. We will add 0. And 8 is divisible by 2 where the index is 1. Now we will get from the max index, we will add to the list. So nums of 3 is equal to 8. We will add it to the result set. And we will store the index of the next one. So now the I becomes the index. So nums of 1 we will add to the list. And now the index becomes 0. Now we will add it to 1 will add it to the return list. So we are maintaining two arrays, which one it stores the maximum length at each particular index, and the other one stores the index of the previous element where it is modulus of. Let's go ahead and code it out. So now initialize the list. If given nums equal to null or nums dot length is equal to 1 is equal to 0, you would just return the result. You don't have to do anything. Now as we talked, we will initialize two arrays of same length. Let me name it length, new int of length, and the other array where we will store the previous index so that we can grab them while creating the return list. Length. We will initialize the length array with 1 because the default length will be 1. If there are no subsets at all, we can just return one element, any of the elements. So arrays dot fill of length comma 1 and arrays dot fill of index. We don't want to store any of the index as a default index because we will be referencing the index of the previous element. So that I will fill it with 1. And we need two more variables, int max, which is the length, maximum length. Right now it's 0, and the max index, which is the index of the last element of the subset with maximum length. Right now it is -1. Now we will loop through the array. 0 I less than nums dot length I plus plus for int. Now j should be starting from I minus 1. The reason is we have taken this array 1, 2, 4, 8. So j should start from I minus 1. That means if I is this, we need to start from this so that we can check if 2 modulus 1 is equal to 0, since we have already sorted the array. So that is the reason we will start from j is -1 and we will go through j is equal to 0. Column j greater than or equal to 0 and j minus minus. So what we need to check? We need to check if nums of I modulus nums of j is equal to 0. If nums of I modulus nums of j is equal to 0, and we need to check if the length is greater than the previous length, maximum length. So that we will check length of j plus 1 greater than length of I. If it is so, what we will do is length of I, we will increase the max subset length at that particular index, length of j plus 1. We will pass through the code once I'm done. Now we need to store the index of the previous element. What does that mean is, so now 1, 2, 4, 8, we know 2 modulus 1 is 0. So what we are doing is in the length array, we are making sure when I is equal to 1, when I is here, we are checking length of j, which is 0 plus 1. Now the length array is 1, 1, 1, 1. Length of j plus 1, which is 2, greater than the length of 1. That means since it is modulus of 1 is equal to 0, now the length of the subset, maximum length of the subset will be 2. So we will update this in length array at that particular index with 2. And we also need to store the index. We know the max index is this, but what is the previous index for this? We need to return the result. So we need to add 1 and 2. So we need to store the index of this value. We will have here index of I is equal to j. We are referencing to the index of the previous element. So index of I equal to j. Once we are out of this loop, what we need to check is if the max less than the length of I, if the subset length is more than the max, what we would do is max is equal to length of I, and the max index, as I was talking, is equal to I. That is it. So this passes through all the array and it stores the maximum index. Now what we need to do is I is equal to max index. So we need to add it to the list. While I greater than or equal to 0, what we need to do is result dot add of nums of I. We'll start from the max index, and now I is equal to index of I, where we'll be getting the previous index element so that we can add it to the result, and we will return result. So let me go ahead and pass through the code. We are initializing two arrays. Let's take this example of 8, 4, 3, 2, 1. Now coming here, we initialize the result. Now the result is basically empty. If nums is equal to null or nums.length is equal to 0, we will be returning this empty list, which is not in this case. So we are initializing two arrays of same length. This is the length array, which we are filling it with all ones, 1, 1. And the other thing is we are initializing the index array, and the index array would be initially -1. We need to sort this array. Looks like I missed that step. Let me go ahead and sort that out. We had this sorted. This array would become 1, 2, 3, 4, 8. So now we have the given array, which is sorted, and the length array with all ones and index with this. And now the max is 0 and max index is equal to -1. Now let's go through this. For the first iteration, I is equal to 0 and j would be 0, but we are checking j would be -1, but we are checking j greater than or equal to 0, so it doesn't go inside. Now it comes to I is equal to 1 and j would be 0. Now what we are doing is nums of I modulus nums of j. Nums of I is this modulus nums of j, which is equal to 0, and length of j plus 1. Length of j is this, plus 1 would be 2, is greater than length of I. So what we are doing, we are changing the length of I to 2. Until this index, the maximum subset is 2, and we are changing the index of I to 0. We will change this to 0 because we know when it comes, there is one more element that we need to add, which is at the 0th index. So we need to add j minus minus, j becomes -1. So we will be out of it. Now the I will be here. I is equal to 2 and j is equal to 1. We will check nums of I modulus nums of j is equal to 0, which is not. We will skip it. Now j becomes 0, where it is true. And what we are doing is length of j plus 1 is greater than length of 2. So we will update this with 2, and we will update the index also to 0, because we can return either of it. So let's say we have a 6 here, then we would know which elements to pass through. So we are out of this. I missed this step. So once it comes out of here, now we'll check max less than length of I, which is in the first case. So max would become 2, and the max index would be I. In this case, it's 1. So now we are here. Now it goes here. We will check if 4 modulus 3, which is not 0, 4 modulus 2, yes. So what we will do is, and it also checks length of j plus 1, which is 2 plus 1, 3 is greater than 1. So until this point, the maximum length is 3, and we will refer the index to 1 at this index. So going forward, it comes here. We will check everything. Oh, yes. And 3 plus 1, 4 greater than 1. So we will replace this with 4. And what we will do is we will store the previous index, which is 3. Now we are out of the loop. The max index is 3 and the maximum subset is 4. Once we are out of the loop, all we need to do is add it to the result. Now I is equal to max index, which is 0, 1, 2, 3, 4. Now the index array is this one, minus 1. Let me clean it up. 0, 0, 1, 3. The index array is here. So what we need to do is result.add of index. Now the first one, nums of I is equal to 4. Nums of 4 is 8. We added it. Now I is equal to index of I. Index of 4, which is 3. Now I will be 3. Now I will add 3, 4, and now I will be index of 3, which is 1. I'll go ahead and add 2, and I is still greater than or equal to 0, and I will add I is equal to the index of 2, which is 0, and I will add 1, and that's it, and I will return the result. I hope this is clear, and this operation takes of n square in the worst case, because we are using 2 for loops here. So the worst case scenario is the order of n square. Let's go ahead and run this out. Yeah, so it's good. So I put clear. All we are doing is we are maintaining the maximum length and the index of the modulus value so that we can populate the result. This is basically a dynamic programming approach. There is another approach where you can do using the depth first search and doing the backtracking. Thank you for watching. Please do like and subscribe to the channel.